Hi, I'm Herman, and I'm a member of the Technical User Relations team at Trilitech. Today, we are going to see how to set up a Tezos Baker using the new Tezos RPI BLS signer. So what's the Tezos RPI BLS signer device? This is a proof of concept for an affordable, open-source hardware signer, specifically designed to sign blocks and consensus operations, that is, pre-attestations and attestations, when using TSET4 addresses, that is the ones powered by the BLS cryptographic scheme. Today, we will assume that you have already assembled your signer device. If you haven't done so, you can follow the links below for the video assembly tutorial and come back later. You will also need a small machine to run a Tezos Baker and the signer on a compatible test network. I went ahead a few steps to save us some time, and I have already set up a Tezos node, a DAL node, and a Baker on the CellNet test network. So when you're ready, let's go together and follow the steps to set up the Tezos RPI signer.
So in this machine, I'm using Octest Ubuntu packages. I'm using V23's second release candidate, as we can see, for instance, by carrying the version of the Octest node. The reasons for this is that we need a version of Octest that can understand the Seoul protocol, and indeed we need to work in a compatible network. So I went ahead and already set up the node, which is bootstrapped on the CellNet test network, and as you can see, there's some operations being injected in the node because I already also set up the Baker with a baking key that it's active and it's getting right. I have also set up a DAL node to track this as a profile, but because I haven't set up the signer, we are sort of halfway there. So the last step before we set up the keys is to actually check that the Octest client can connect to the signer. So I have plugged in my Tezos RPI BLS signer, I input my password, I run the signer. So if after I have done all that steps, the Octest client should be able to list the known remote keys. In particular, we need to put the address and the port the RPI BLS signer uses. And as you can see, it shows that we have two addresses that are being served from the signer. And if this is the case, we are ready to go. If it's not the case, you might want to check the troubleshooting section of our installation guide. So as we said, the signer provides two keys. This is because one is intended to be used as the Baker's consensus key and the other is intended to be used as the Baker's DAL companion key. So what are the DAL companion keys? This is a new concept introduced by the Seoul protocol. These keys are intended to sign the DAL part of an attestation when we are using a TSET4 consensus key. If you're using other addresses, TSET 1, 2, or 3, as a consensus key, you don't need to set up that companion key. But here, in the case of the BLS signer, we are expecting to need both. So we will import actually both keys. And we use this with the usual command, import the secret key, and we will name the first one consensus key, and we are going to use here the address and the port of the BLS signer, and we are going to choose the first one as consensus key. This is just the name, right? And of course, we are going to use the second one as companion key. Just let's, of course, import this key as companion key. Okay, now what we have done is enable the Octest client to access the keys in the signer to assign blocks and attestations and pre-attestations and the payloads, right? So, but we still are not there yet. Now we need to set these addresses as respectively consensus keys and DAL companion keys. So we do this, of course, with the already known command for setting a consensus key for the Baker address to consensus key. This will, of course, inject an operation. The operation has been successful. Now we will do the same. Okay, so now we have successfully declared what are our consensus key and our DAL companion key, but the effect of these operations is not immediate. We need to wait at least 2 full cycles and the next. So basically, we will be able to use these keys in 3 cycles. And in the meantime, what we are going to do is we are going to set up our baker to be able to use these keys. So in my case, I will do this with the interface for configuring the optics packages while we wait. Baker, don't spy on my key. And here we just will call key and we just write. So here in the baker key line, we're going to add to our baking key the consensus key and the companion key. We'll need to keep the 3 keys around as our main baking key still has writes for the next few cycles. So we are going to quit here and we are going to update our services. Now just restarting the baker to use the new keys as well. As we said before, these changes will take effect in a few cycles, so we'll be back in around 40 minutes or so to show how the Tezos RPI BLS signer and its keys have taken our baking in this machine. See you in a bit. So we are back after a few cycles, and now our baker should be using the Tezos RPI BLS signer for signing consensus operations. I will see it immediately here in our baking logs, as we have seen that we are injecting attestations at the level for the delegate with the consensus key from the Tezos signer, and immediately here we spot a level where we have DAL participation. We'll see also the companion key listed in as well. And of course, if you go back to the beginning of the video, you will see that we are not injecting the DAL payloads correctly because we haven't set up the companion key, which now our companion key is correctly set, the consensus key is correctly set. We also see this in the logs for the DAL node here, as we have switched. You see this message that we are attesting the only slot that is being produced at the moment, which is slot 0, and we are getting all the shards, whereas if you go back at the beginning of the video, we were saying that we were not getting the shards from this slot. So one last way to check how everything's going is we're going to fetch the public key hashes. We are going to use the Tezos RPC endpoint to indeed see the stats for the baker in the cycles. So we're going to connect to this. It's a bit of long information, so we're out more. Remember, this is the baking key that we are carrying here in the context. We're going to see indeed that we haven't missed any attestation this cycle because the Tezos RPI BLS signer is quite fast. So, and also that we have indeed fulfilled all the attestations that needed DAL payload. Going a bit further down below, you will see indeed that the consensus key is active and the companion key is also active. This can be carried, of course, by looking at the delegate endpoint or also in the block explorer using the SKTIO. You will get all this information as well. So I think that's all for today. I look forward to hearing your feedback using the Tezos RPI BLS signer on SeulNet, hopefully pretty soon on Tezos mainnet. See you next time.